All right, hey, what's up, everybody? Mr. Fortney here, and just got done with our second class of doing constructions. The big one that you got today was perpendicular bisector. I'm calling that construction number 8 because we did the rhombus right before that was construction number 7. Last class, the in-center, that was construction number 6. Before that was angle bisector SSS method. Before that was the copy angle construction number 4. So anyways, hopefully you're keeping track of these. You got to figure out, how do I stay organized? How do I actually do it? So perpendicular bisector one we'll be doing a bunch. I'll make it nice and quick. Say I have a segment. I know that segment, I want to find its midpoint. Okay, if I want to find its midpoint, if I knew where the perpendicular bisector was, well, the perpendicular bisector, that's the one line that this segment has that intersects this segment perpendicularly at its midpoint, right? It bisects the segments, so it goes to the midpoint, and it's perpendicular to it. It's the one line that does that, that's in this plane, right? The plane being the chalkboard we see here, or whiteboard. Anyways, the way we do this, we do the rhombus method to do this here. So check it out. It should be pretty easy. I'm not going to write it out step by step like I did in class. This is all you do. Set your radius so that you can draw a freaking rhombus, okay? Put the center at the end of one of the endpoints, and you just define a distance. This arc, you draw an arc above. You usually draw an arc above, and we'll draw the arc below later, okay? So I know that all those points are this radius, this length away from this endpoint. Okay, and I know that these points here, I'll do the same thing. I'll center it on that endpoint, draw an arc that intersects. I know all those points are the same distance, equidistant from point B. This is in the center of a circle. This is remember the outer ends here is just part of those points of that circle. So I know that this point here, D, make it mark D, that point D is on the perpendicular bisector of segment AB, because one thing we proved last semester was that if a point is the same distance, and it is, because what did my radius change? It didn't change on my tool, right, when I drew my arcs. That if a point is the same distance away from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. Okay, so here, I'm not going to draw the rhombus in, but here, AD would equal DB. And if I did the same thing down below, right, that's what I want to do, same thing down below. Some people actually do the entire arc here, so it actually kind of connects, but you don't have to do that. That's kind of showing too much. Again, my objective is just to use the geometric properties to justify construction. Show enough evidence in your construction markets. So you could draw the whole thing there, almost draw like a semicircle here. But really, all I'm asking is you don't change your radius, you just draw the arc, okay? Where they intersect, I know that those 2 points here, D and C, are on the perpendicular bisector. So can I construct that perpendicular bisector? Well, through 2 points, exactly one line can be drawn. So if I just draw that one line, what do I know about it? Those 2 points are on the perpendicular bisector, so I know that that must be the perpendicular bisector that's in this plane for that segment here. So yoink, 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 construction done. I know that this is what? This is the midpoint too, so I found the midpoint. It's the same method, right? Same method to find the midpoint, just find the perpendicular bisector, and then point of intersection, that's the midpoint of segment AB. Thanks for watching. Another video coming up next, construction number 9, 45, 45, 90 degree triangle. I'm going to add on to this.